Students, this is our lecture 5 of our video lecture series of ST, of course, STMJ 241, continuous probability distribution and sampling distribution. Uh, we have started the first chapter, Univariate continuous probability distribution. This is our fifth lecture. The content of our today's lecture is we will discuss median and quartiles, mode, and Jacobian transformation. So let's start with the first concept, median and quartiles. Median and quartiles. First discuss the concept of median. Suppose capital X is continuous random variable. X is continuous random variable. F of X is its PDF. Then the median is obtained. What is median? Median is nothing but the middlemost observation. And if you solve probability of X less than or equal to capital M, solve probability of X less than or equal to capital M is equals to 0.5. Suppose this is the graph of some PDF, graph of some function f of x. So median is that value for which the area should be 50%. So probability of x, solve this, probability of x less than equals to 0.5. So you will get the value of m. तर हे तुम्ही आणखीन एक स्टेप सॉल्व्ह केलं f of 0.5. मला हे सॉल्व्ह केल्यानंतर m ची व्हॅल्यू मिळेल. Similarly, you can obtain quartiles. If you want to obtain quartile Q1, solve probability of x than or equal to Q1 equals to 0.25. Solve this, you will get the value of Q1. Obtain Q3, solve probability of x less than or equal to Q3 equal to 0.6. This implies of Q3 is equals to 0.7. तर या पद्धतीने आपल्याला क्वार्टाइल्स आणि मीडियन काढावे लागतात. एक एक्झाम्पल यावरचं बघूया. Let's take one example. Let fx is equals to upon 2, 0 less than x less than 2 upon b minus c2 minus yes. Find median and quartiles Q1. Also obtain quartile deviation. तर क्वार्टाइल्स कसे काढायचे? क्वार्टाइल आणि मीडियन काढण्यासाठी अगोदर आपल्याला डिस्ट्रीब्यूशन फंक्शन काढून घ्यावं लागतं. So first of all, find out distribution function capital X. Capital Fx is integration from minus infinity x f of t dt. The lower limit is here, it is 0, upper limit is x, t is 1 upon 2 dt. solve this 1 upon 2 outside. So it is capital F of x is x upon 2 for 0 less than or equal to x less. So here we have obtained capital F of x. And now use this, we will use this capital F of x in order to obtain median and to obtain Q1 solve probability of x less than Q1 is equals to 0.20. That is, this implies f of Q1 is equals to 0.20. So this implies what is fx? Fx is x upon 2. So f of Q1 will be Q1 by 2 equals to 0.25. This implies Q1 is equals to 0. Similarly, we can obtain Q2 and Q3. Q2 is median. Okay. To obtain median, solve probability of x less than or equal to Q2 is equals to 0.50. Right? Okay. Sorry for the disturbance. So to obtain Q2, solve probability of x less than or equal to Q2 is equal to 0.50. This is nothing but f of Q2 is equals to 0.50. f of x is x upon 2. So this is q2 upon 2. f of x आहे x upon 2. f of q2 या ठिकाणी मिळणार आपल्याला q2 upon 2. सॉल्व करूयात. q2 या ठिकाणी आपल्याला मिळालेलं आहे q2 0.50 multiplied by 2 is now obtain q3. To obtain q3 we have to solve probability of x is equals to 0.75. This is nothing but f of q3. f of q3 या ठिकाणी काय येणार? f of x is x upon 2. So this is q3 is to 0.75. This implies q3 is equals to 0.75 multiplied by 2, 1 point. In this way, we can obtain the quartile. Next, they also asked to find out the quartile deviation. Quartile deviation is q3 minus q1 divided by 2. Quartileच्या व्हॅल्यू या ठिकाणी पुट करा. Is 1.50 minus q1 is, let's check here, q1 is 0.50. It is 1 upon 2, 0. That's it. In this way, we can obtain the quartile deviation. Okay. Now, next concept is mode. In FYBSC, we have learned that mode is, for discrete data, mode is that value of x for which the observation is repeated maximum times. That is the observation which has the maximum frequency. That is called as mode. Discrete probability distribution. x and px, we say that that value of x is mode for which the probability is maximum. And in case of continuous distribution, mode is that value for which the function is maximum. Mode is a value of x, that value of x, mode is that value of x for which f of x is maximum. Mode is that value of x for which function is maximizes. And in 12th standard, we learn that how to find the maxima of any given function. So we use the differentiation concept there. Suppose x is continuous random variable. F of x is its PDF. Its PDF. Then, in order to find out the mode, mode is that value of x for which solve to obtain mode. Obtain mode. Solve f dash of x equals to 0 and f double dash x should be less than 0. आधी f dash of x is equal to 0 हे सॉल्व करून घ्यायचं. त्याचे जे काही रूट्स येतील, whatever the roots we obtain by solving this equation, for those values of x, that value of x is mode for which f double dash x is less than. That's it. This is the concept. This is the definition. Let's solve one example basis of this mode. F of x is equal to x square by 2 e raised to minus x x greater than or equals to 0, 0 otherwise. So for this PDF, for the following PDF, find mode. What is f of x here? Square upon 2 e raised to minus x. Now, we know that if the if two functions are one functions, then the maxima of both function is same. So if we solve this function, if we solve for this function by taking the differentiation, it is little bit difficult. Then if we take the log of this function f of x and then we differentiate that log, that will be quite easier than proceeding with the original function. Okay, so we will first take log and then then we continue the procedure. This one. The first step is take log on both sides. Log of f. जर दोन फंक्शन हे वन फंक्शन असतील तर ओरिजिनल फंक्शन आणि त्याचं लॉग, तर एफ एक्स आणि लॉग हे दोघं वन फंक्शन असतात. या फंक्शनचा मॅक्झिमा आणि लॉगचा मॅक्झिमा हा सेम असतो. म्हणून या फंक्शनला डील न करता आपण जर लॉगला डील केलं ते जास्त सोपं होणार आहे. म्हणून आपण या ठिकाणी लॉग घेऊन ही प्रोसिजर लॉगच्या फंक्शनसाठी आपण ही प्रोसिजर अप्लाय करणार. So to take the log of fx is minus log 2 plus times log x. Now differentiate. After differentiating log of fx, the derivative of log of fx dash x this is 0 2 times log x, derivative of log x is 1 upon x minus the derivative of x is 1. Dash x equals to f of x into 2 upon x minus 1. Now call f dash of x is equal to 0. This implies 2 upon either this fx 0 or 2 upon x minus 1 equal to. But fx is PDF, so it should not be 0. 2 of x minus 1 is only 0. This implies 2 minus x equals to 0. This implies x equals to. So this x will be mode if you obtain the f double dash x, and if you put the x is equal to 2 in the second derivative, if it is negative, if that f dash of x at x is equal to 2, तर हे निगेटिव्ह आलं तर आपण असं म्हणूयात की एक 2 is mode for the given. So take the second derivative f double dash x. Of x derivative of f of x is f dash x. Put another function as it is. Plus, now keep fx as it is. Now differentiation this one. Derivative of this is 0. 2 upon x derivative is minus 2 upon x square. Now put x is equal to 2 in f double dash x. F double dash x at x is equal to 2. This 2 will get cancelled. This will be 0. If you put the value of x is equal to 2 here, so this is minus 2 upon 4. So this is negative quantity. So f double dash at x is equal to 2 is less than 0. Therefore, by the definition of mode, x is equal to 2 is mode. So this way we have to obtain the value of. Okay. Now the last concept of our today's lecture content is transformation of variables. So what is this concept? Suppose we have the random variable x. X is continuous random variable. And if you want to find out the probability distribution of y equals to some g of x, this is the transformation. So we have one continuous random variable and f of x is its PDF. Of x is its PDF. If we want to find out the probability distribution of y is equal to g of x, then we find out this probability distribution of y by this technique, transformation of variable. There are 3 methods by which we can find out the probability distribution. Okay, so there are 3 methods. First one is Jacobian. Transformation. Second is by using distribution function approach. And the third one is MGF approach. Okay. So Jacobian transformation is used when the function is 1 1. Distribution function approach we will use if the function is not 1 1. Not 1 1. It means if the function is many to 1, can use distribution function approach. Okay. MJF approach generally it is used in case of when we have to prove the additive properties. This is not only the case, prove the additive property. Also, one can use this in a 1 1 function approach also. These are the three different methods of transformation. Let's see one example for this transformation. Let's consider the PDF fx equals to 1 upon pi multiplied by 1 upon 1 plus x square. Find PDF of y equals to tan inverse x. So we will solve this example by using a Jacobian transformation approach. Why so? Because this transformation y is equal to tan inverse x. If you observe the graph of this function, that is the 1 1 function. So how to proceed? How to solve this example? Here fx is so let y equals to tan inverse x. If differentiate this, the derivative of tan inverse x is 1 upon plus x square. This implies dx upon dy equals to 1 plus x square. This implies mod of, we need mod of dx upon dy. Is itself again 1 plus x square. Okay. Now the next one is we have to find out the limits. Limits for y. So step is limits of y. So what is y here? Y is equal to tan inverse x. What are the limits of x? Limits of x are minus infinity than x. So if you put x is equal to minus infinity, y is equals to tan inverse of minus infinity is minus pi by 2. If you put x is equal to infinity, y is equal to tan inverse of infinity is plus. So the limits of y are minus infinity less than y. I'm sorry, minus pi by 2, then y, then now by Jacobian transformation, the formula is f of y is equals to fx mod dx dy. This is the formula. Put the values. Fx is 1 upon pi into 1 upon 1 plus x square. Multiplied by mod of dx upon dy is 1 plus 1 plus x square, 1 plus x square, this get cancelled. simply 1 upon pi. The limits of y are minus otherwise. So this is the PDF of y. F of y is 1 upon pi minus pi by 2 less than y less than. So in this way, we can obtain the probability distribution by using Jacobian transformation. Let's solve the next example, which is based on the Jacobian transformation. If capital X is random variable taking values in minus a to a, has PDF f of x. Question is find PDF of y equals to x square and y equals to mod x. So this is the question based on distribution function approach. Now clearly you can observe this y is equal to x square function and y is equal to mod x function. Both are not 1 1. Y is equal to x square, this any to 1 function. Y is equal to mod x. What is the graph of y is equal to x square? This is the graph of y is equal to. This is many to 1 function. Y is equal to mod x, graph is this. Again this is many to 1 function. Both functions are many to 1 function, so for which cannot use the Jacobian transformation approach. For this example, for this transformation, we will use distribution function approach. Let's solve the first part. So first of all, we will find out the distribution function. Probability of y, small y. Put the value y is equal to x square. This is probability of minus probability of a less than x less than b for continuous is nothing but f of b. F of b minus f of a. So this is the distribution function. And now since this y is equal to x square, this is even function. Therefore, since this is the even function, therefore f of root y equals to f of minus root y. This is now this is the distribution function. Now differentiate this. Differentiate with respect to y. Dash of y. The derivative of distribution function is PDF. Derivative of this capital F of root y is 1 upon 2 times root y minus 1 upon 2 times minus root y. Okay, this is 1 upon 2 times minus root y minus minus plus of so which is equals to f of root y. I'm sorry, the derivative 1 upon 2 times root. derivative of this capital of something na 1 upon 2 times root y of root y or f of root y is plus upon 2 times root y of minus. So since the function is even function, therefore f of root y equals to f of minus root. So this is equals to 2 times of 2 to get cancel f of root y on upon root y only. And what is the range of this y here? As x is from minus a to a, to take its square, the 0 y less than this way. Similarly, you can obtain the probability distribution of mod x also. Let's consider f of y equals to probability of y less than or equal to small y mod x y this is f of b minus f of a now differentiate this to y of y, or you may call this as g of y. Derivative of distribution function is simply minus minus plus. So it is 2 times f of y. So to solve this kind of examples, you have to PDF is provided. Just plug the values of PDF here, example, and hence you can obtain probability distribution. Again, x is from minus a to a. If you take the mod 0 less than y, 0. This way we have to solve the problem of Jacobian. So that's it for the today. So students, in the today's lecture, we have discussed median and quartiles, then mode, and the last one, transformation of random variable. So that's it for the today, and the first chapter of this course is over here. The next lecture, we will start the new chapter, normal distribution. So for today, stop here. Thank you.